So here we have a problem. A block slides along a track from one level to another level. By moving through immediate valley, the track is frictionless until the block reaches the higher level. This part is friction. There's a friction force stop the block in a distance of d. The block initial speed is 6 meters per second. The height difference, h, is 1.1 meters, and the coefficient of kinetic energy, mu, is 0.6. The value of d is, he wants to know the distance once it hits this level it will take to stop. Well, let's see if we can so what we'll do is use the mechanical energy formula and tack on a non-conservative force times a distance in order to get this frictional force right here, get this distance. So let's start. Here, mgh initial. Well, that's going to be 0. We'll do that right now. Plus 1/2 mv square initial. Well, they gave us 6 meters per second, so we'll put 6 meters per second square is equal to, well, we got this height, which would be mg h final, which is in the height is given to us as 1.1 meters, plus 1/2 mv square final. Well, we're going to come to a stop on this friction portion here, so that'll equal 0. Plus a friction force, Fk, times d. So that's work. That's the work the friction force is doing, which is going to dissipate as heat. So let's solve this. First, we need to do Fk. Now, Fk is equal to mu times n. And for a flat surface, we're going to just skip a step because we know that that's mu times mg. Maybe I better show that with a force diagram. That's n on our block. This is mg. So n minus mg equals ma. Now we know there's no acceleration in the y direction, so that's equal to 0. And that will go to n equals mg. Now Fk is mu times E, n. So Fk is equal to mu times mg. And we'll stick that up here. So we have 1/2 mass 6 meters per second square is equal to mg times 1.1 plus mu times m. All right. And this is the distance that we're looking for. So we got mu, which is given to us as 0.6, 0.6, g times the d we're looking for. It's going to equal 1/2 6 squared. This goes on the other side, so that's minus 9.8 times 1.1. So D is going to equal, we know 6 squared is 36, and half of that is 18, so we put 18. Minus 9.8 times 1.1. That's equal 10.78. And we got 0.06 times g going on the bottom. So that's 0.06 times 9.8. And that is 0.588. Got a slight. That's 0.6 times 9.8. So 0.6 times 9.8 is 5.88. Let me put this decimal right here. It's in the wrong place. That's 5.88. And when we solve for D, so solving for D, we're going to get 7.22, that's 18 minus 10.78, over 5.88. That came from the coefficient of friction, kinetic friction, 0.6, times G, which that's what that is, 5.88. And when you put that in your calculator, you get a distance of 1.23 meters. That's your stopping distance. And what's important is that we use our mechanical energy and a non-conservative force, which is the energy that was left over when it got to this point. So we just set that with this non-conservative force times D. And we solve for the normal. And we know that mu times mg is equal to Fk. We plugged it in, and then we just solved for D, and we got D equal 1.23 meters. That's it for this problem.